Another reason why Europa might not be habitable. Artemis II is delayed for a month. Claude takes Perseverance for a spin. SpaceX is planning to launch up to 1 million satellites. All this and more in this week's Space Bites. We recently covered research about how Europa might be less habitable than previously believed. And this evidence comes from my friend, Dr. Paul Byrne, and I did an interview here on the channel. And the gist of his research is that, the big argument on why there could be life under the ice on Europa is that there is some kind of process on Europa that is allowing minerals to get from the crust of Europa into this ocean that is beneath this thick sheet of ice. They ran through all the possible sources like hydrothermal vents and fault lines and sea quakes and serpentization, and they weren't able to find any mechanism that would allow these minerals to be able to constantly, continuously mix into the water. So bottom up, we're not getting a source of minerals that are making their way into the ocean of Europa. That means that you could have this foundation for life on Europa. But what about top down? Could you have mechanisms that are taking space dust that is falling onto the surface of Europa, and then they're making their way, trickling down through gaps and cracks in the ice down into the ocean underneath? And it all just depends on the thickness of the ice. When NASA's Galileo spacecraft went to Jupiter and did a lot of observations of Europa, it found evidence of chaotic terrain on Europa, places where the ice sheet is cracking and you're getting this jumbled terrain on the surface and potentially upwelling from the ocean underneath. But how thick is this ice shell? And so this is a question that astronomers have tried to answer with NASA's Juno spacecraft. It used its microwave radiometer, which contains 6 different antennae, and they reviewed the surface of the ice and made an estimate that the sheet is anywhere between 3 and 30 kilometers thick. And I know that is a very wide range. If you get 3 kilometers, then there's probably a lot of mechanisms for material to get from the surface down into the ocean. If it's 30 kilometers or thicker, it gets harder and harder to be able to do that. And it really depends on the salinity of the material underneath the ice and what other chemicals are already in it. If it's just pure water ice, the researchers estimate that it could be 30 kilometers plus or minus 10 kilometers, so maybe up to 40 kilometers thick. And this just shows that we really need the Europa Clipper to arrive at Europa, because it is going to be doing 50 flybys of Europa. It has an ice penetrating radar system that will allow it to see beneath the surface of the ice and map out how deep the cracks and reservoirs go and where does the ocean begin, or it can't see it because it's too thick. So it just shows that now we sort of reached how far we can get with the instruments that we have available, and now fortunately the right tool is on its way to Europa to try and give us better answers. We've got a story about this from Evan Goff on Universe Today. But then we've got another story about Europa that shows the story is even more complicated than we thought. So astronomers were going through old data from the Galileo spacecraft, which I mentioned earlier. This is the mission that was mostly observing Jupiter, but was also looking at Europa and the other moons of Jupiter. And scientists were looking at this archival data from Galileo and noticed this faint presence of ammonia on the surface of Europa near where you have these cracks on the surface. And this is important for a bunch of reasons. So the first thing is that ammonia cannot survive in the conditions out in space for very long, which means that you're seeing this ammonia on the surface, then it upwelled from within Europa relatively recently. The other thing is that Europa contains nitrogen, and nitrogen is one of the elements that is used by life. And so you've got chemicals potentially used by life that are upwelling from some reservoir underneath the surface of Europa. And so that's in direct contradiction from the possibility that it's a very thick ice sheet, no material is making its way up. So obviously this is still totally in flux. And again, we need Europa Clipper to get to Europa. And we've got a story about that from Carolyn Collins-Peterson. And then you've got that interview that I did with Dr. Paul Byrne here on the channel about the potential for minerals being able to make their way at the bottom of the ocean. NASA's Artemis II mission is on the launch pad and was expected to launch within just a couple of days of when I'm recording this episode. And in order to get to the place where they can do the launch, they need to go through a wet dress rehearsal. This is where they go through all of the steps of preparing the rocket for launch. They fill the tanks, they prepare all the electronics, all of the hardware that's associated, go through all of the steps, and then they go down to a handful of seconds from when they're about to launch, and then they stop, and then they detank all the propellant, and they go back, reset, so that they're ready to do the actual launch on the day of the flight. So as they were tanking the core stage of the Space Launch System, the big rocket, they noticed that there was a problem with a hydrogen leak as they were putting propellant into the core stage. They were able to troubleshoot that problem and get closer until they got to a full tanking of the rocket, and then they proceeded with the countdown. They got down to 5 minutes from that simulated launch point and then decided to call off the test. And then we learned later that NASA has decided to push the launch back for a month. And not just for this issue of a potential hydrogen leak, there's also issues with the Orion crew module, hatch pressurization, and then a couple of other issues that they're looking at as well. And, this doesn't surprise me. I think when I recently reported on this, that you should be totally prepared for monthly delays as necessary, because of course you can only launch when the moon is in the right position, and then you have to wait until the moon returns back to its position. So you've got a couple of days to do your launch, and then you have to wait for the moon window to open back up again. And so now they're going to be able to fix and deal with all those issues. We're going to go through the whole thing again, another wet dress rehearsal, and then hopefully in early March, we will see the launch of Artemis II. I've got a story about this from Matt Williams. It's pretty cool that we have rovers on the surface of Mars right now, but the big challenge in dealing with a Mars rover is that the delays in communication really add up. In the best case scenario, you've still got just under 10 minutes for return communication to and from Mars. And in the worst case scenario, you're looking at 40 minutes to communicate back and forth from Mars. And so imagine if you're trying to plan out a route on Mars where you got to go to this rock, go to the right of that rock over there, now go around here. As you wait for it to execute each one of these maneuvers, your time stretches out, and that means you're doing less science while you wait for communication to go from you to Curiosity or Perseverance and back. And so as an experiment, NASA wanted to see if you could put control of the rover, the route finding, in the hands of a large language model. In this case, they chose Claude from Anthropic. And so they gave Claude the same information that the human route planners get, where it had maps, interesting geological things, knew the sort of overall route that it was supposed to get, and then it was able to plan out a route through the terrain autonomously, and then they use that for Perseverance. Now, obviously, it still has to deal with that communication time back and forth, but imagine if a more advanced, more specialized version of this kind of a model is actually placed on the rover itself. Now it has the information locally. It's able to make these kinds of decisions on the fly without any human intervention. You can imagine a future where the science doesn't have to slow down because the rover is able to just make its decisions as quickly as it can from a kind of geology perspective. Of course, AI is sort of making inroads into everything, including our business. So if you want to sort of see my perspective on that, I'll put a video in the show notes. Remember when SpaceX informed the government that they were planning on launching 30,000 Starlink communication satellites over the next couple of years? Well, that's just adorable, because now they say they want to launch up to 1 million satellites. And these aren't going to be the same telecommunication satellites. The plan is that they're going to launch data center satellites into space with Starship. Of course, one of the problems is that AI is eating the world right now, and that data centers are constrained in terms of power, in terms of chips, in terms of places that you can put these data centers. And so one of the ideas that several companies are floating, pardon the pun, like Google and like XAI, is what if we launched our data centers into space? They have continuous access to power. You would have less hardware required. You wouldn't need the same amounts of glass. Think, in theory, you could have these data centers be in space and then be able to beam the results of their calculations back down to Earth. And in several interviews, Elon Musk has been making predictions for what is going to happen with the future of SpaceX and with XAI that sound like right out of science fiction. He has suggested that there might be terawatts worth of power used in compute that is launched into space, both from the Earth and eventually from the moon, where you would have robotic facilities on the moon that are producing these data center satellites and then using a mass driver to launch them into space. And in order to make this happen, he is anticipating that SpaceX is going to need to go public, which is the first thing, and that SpaceX and XAI, which was once Twitter, is all going to need to be merged together into one company. That XAI will be developing the data center satellites and SpaceX will be launching them. And in theory, you could see 30 starships that are launching, say, 10,000 times a year, launching all of these data center satellites into space and, of course, sending more material to the moon. And under a short consultation with himself, Elon Musk decided that SpaceX should acquire XAI. So now that merger has been completed, and that this is what they consider to be the natural connection between what SpaceX and how XAI will work together to increase the valuation of the public company that's about to come out. Now, I am skeptical, and I'm not the only one, that building data center satellites and launching them into space is going to make more sense than just building renewable power down here on Earth and running your data centers that way. Launching things into space is incredibly expensive, and we have seen a long line of, we're going to do this thing in space, asteroid mining, space power in space, so many other ideas that once you deal with the, well, how are we going to go to space and make this profitable, the idea no longer makes any sense. I am unconvinced that this is the most viable way to deal with the voracious need for both power and compute is to launch these things into space. And again, I'm not the only person. There are plenty of other people who know way more than me who are very skeptical of this idea. Now, we'll see what happens. I guess we'll wait and see if they can pull it off. But hopefully they don't get distracted from the need to bring humans to the surface of the moon as part of the Artemis II mission. Now, we've got a story about this that goes into all the details of what all the plans are by Alan Boyle, and he has done just incredible coverage of this story. And so if there's like one story you absolutely should read out of this week's episode of Space Bites, definitely read that one. And of course, one reason why SpaceX should really focus and make sure that they're able to carry humans to the surface of the moon is because Blue Origin has gotten very, very serious. So serious that they have put a pause on their New Shepard flight. Now, New Shepard is, of course, the suborbital launch rocket that they have been flying for the last couple of years. They've done 38 flights with 98 humans on board. They've carried them above the Kármán line and demonstrated that they can take off with their rockets. The rockets can land near the launch pad, that they can bring the humans safely down to Earth. And they've decided to pause New Shepard so they can focus on New Glenn and all of the opportunity that exists now with getting this enormous rocket flying. If SpaceX is not able to get the human landing system delivered in time for Artemis III, maybe they'll have to switch over to the lunar lander offered by Blue Origin. And so this allows them to retask all of the engineers, all the designers on getting New Glenn operating and picking up the pace of their launches, which has taken a long time, and they are not launching very many rockets compared to SpaceX. Once again, the universe has demonstrated that it is able to make all of the precursors of life just in deep space itself. If you've been following along, it's just like almost every week, astronomers announce a new molecule that has been found out there in the universe. Obviously, we see water, carbon dioxide, carbon monoxide. We see hydrocarbons, ethanol, methane, hundreds of amino acids, including the 20 amino acids used by life, just out there in space. We see alcohols. We see the parts of even simple proteins, simple sugars. Like, it's really just amazing how much of the building blocks of life are already present in these giant star-forming clouds of gas out there across the universe. And now astronomers have added another one. So this one is called thiopine, and it's a ring-shaped sulfur-bearing hydrocarbon that is produced in biochemical reactions. And what's exciting is that it has 13 atoms that are part of this molecule. Sulfur molecules have been seen before, but nothing above 6 atoms. And so now you've got one that is 13 atoms that is being produced naturally. And this molecule was detected in a cloud of gas that is 27,000 light years away near the center of the Milky Way. And so when we think about this idea of abiogenesis, where did life come from here on planet Earth? It appears that all of the raw material were delivered. We don't just need the material to have come together in some puddle on the surface of the Earth, zapped by a lightning or at the bottom of a hydrothermal vent. All of the raw material arrived to Earth as necessary, and it makes the rise of life feel inevitable, which matches that as early as life could have formed on Earth, it did. I'm sure at some point we're like, well, we've detected RNA in space or DNA in space. It'd be kind of amazing. We've got a story about this from Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best space news story. And the winner last week was that NASA is investigating nuclear rockets again. So thank you everybody who voted. Now we're going to put a vote in the channel here in the post tab. At the time you're watching this, the vote will be there. But if you don't see it right now, just go into the post tab on our channel and then you will be able to see all of the previous polls, vote a bunch of times, and then they should start showing up in your feed. Of course, you should also be subscribed to the channel. Click on the notifications bell. Obey the algorithm. The surfaces of the moon and Mars are bathed in radiation, very dangerous. It'd be nice to be able to get out of that cosmic radiation below the surface in a place that is protected. Hilarious Canadian accent, spoiler alert. And of course, lava tubes have been seen on both the moon and Mars, and these are considered some of the most interesting places to explore on these worlds. We know we have lava tubes here on Earth. Could there be lava tubes on Venus? Well, it all depends on the level of volcanism that's happening on Venus. We know that there is relatively recent volcanic activity, and there are hints of the kinds of structures on Venus that could be supporting lava tubes. The problem is that the best resolution images that we have were from NASA's Magellan spacecraft, which took its surface data back in the 1990s. And so you just don't have the kind of resolution to see the pits and the skylights that we see on the moon and Mars. But researchers did some calculations and simulations to get a sense of what would be supported on Venus, which has very similar gravity and composition to Earth. And they found that lava tubes with widths of a few hundred meters would probably remain stable. And so with new missions with higher resolution, they should be able to observe the kinds of surface features that could be connected to lava tubes down below, like pit chains, skylights, and subsurface voids. So stay tuned. This is why we want spacecraft to go back to Venus and capture images from space. Got a story about this from Lawrence Tignetti. Now let's see some cool pictures and videos of space. So first up, we've got a new simulation from NASA about how the magnetic fields of neutron stars interact as they are about to collide and merge. And we know that neutron stars have some of the most powerful magnetic fields in the universe. And there's like a certain variety called the magnetar, which is even more powerful. And so NASA researchers did a simulation to find out how the magnetic fields will interact as the two neutron stars are getting closer and closer and eventually are going to merge. And when you have these powerful magnetic fields packed in really tightly, you'll get gamma radiation coming from the region around the neutron stars. And so theoretically, this tells you a place to look for signals that will inform you that a neutron star collision is about to happen. And so maybe we'll get advance notice of a place where neutron star collisions are going to happen. But I really like the simulation. And one idea is that merging neutron stars could be how you get magnetars, which are the most powerful magnetic fields that we know of in the universe. I've got a story with Dr. Genevieve Schroeder about this idea and her search for the birth of magnetars. And then we've got a new record for the most distant galaxy ever observed. And I warned you, this record will break again, but the new candidate is called MOMZ14. And this is a galaxy that we've known about for a while. And generally you get these observations in two stages. One is a fairly simple observation by James Webb that gives a sense that one of these galaxies is very far away. And then they do a follow-on observation with Webb's near infrared spectrograph. They're looking for the spectra of the galaxy, which will confirm its actual redshift distance. And they got the redshift to 14.44. And that corresponds to 280 million years after the Big Bang. This is just one of an example of a bunch of surprisingly massive, surprisingly mature galaxies seen really moments after the Big Bang, that you're already seeing heavier elements in this galaxy that it was believed would take a little bit longer for the kinds of concentrations to build up. So this is the record. Mom's Z14. Expect another one to take this record any day now. I hope you're enjoying all of the stories that we have here on Space Bites this week. But if you're watching this on YouTube, you probably had to watch an ad before you watch this video. Well, we would prefer that you didn't watch ads. And so we make a version of this exact same video and put over on Patreon that is completely ad free. And you don't have to subscribe, you don't have to join, you don't have to pay us any money. You can just watch it for free. And to reward you, to show you that this is a better experience, we will add one additional story into Space Bites. And the bonus story this week is how astronomers are looking through archival data to make new discoveries that were never seen before. So I'll put a link in the show notes. You can click over and watch the version over on Patreon that is no ads and has the extra story. Check it out. And if you want even more space news, of course, I run the Universe Today website, which is one of the longest running space news websites on the internet. And every week we cover 30 to 40 stories about space and astronomy, a lot more things than we have time to talk about here in Space Bites. But if you want a nice summary of everything that we're covering on Universe Today, you should subscribe to my weekly email newsletter, which I write every Friday. It contains overview of every single story that we're covering. I write it in my own voice. There's no AI. There's no ads in the newsletter. It's completely free. You can get it from universetoday.com/newsletter. All right, I'm going to talk about my fondness for canceled missions. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barry Lake Roofing, Brian Bodie, Caradon, Chuck Hawkins, Commander Bailock, Cy Nelson, Dark Finger, David Giltonen, David Matz, Evan.Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Steve Farley Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. Whoever controls the spice controls the universe, and we give the patrons the ability to control the spice, to choose a rant that I will give. Now, sometimes it is a real rant, and sometimes it's just a trap for me to rant about something that I'm absolutely fascinated with. And so Ryan Q has chosen the latter. I've always been fascinated by space missions that were proposed, but ultimately canceled or not selected. What were the scientific objectives, the reasons they weren't chosen, the technical challenges they would have faced, and what future might still hold for those ideas? So this is just the outro of a video, and so I can't go into all of the detail, but in general, there are a lot of really amazing ideas that never ended up working. And there's no one reason why. So I want to give you just like a bunch of examples of the kinds of missions that I am fascinated with and how they could have changed the future of astronomy and space exploration if they had actually happened. And so the classic example of this is the Apollo missions that would have come after Apollo 17. So Apollo 18, 19, 20. And the plan was to just continue with building infrastructure on the moon, a longer term lunar base, maybe a telescope that would be operated from the moon by the astronauts. So there's a lot of ideas. And if you watch For All Mankind, you get kind of a sense of that sort of continued human presence on the moon. The mission that I will always talk about as the one that makes me the saddest is the terrestrial planet finder. And this is a mission that was proposed more than 25 years ago. And this was going to be an interferometer that would directly observe Earth-sized worlds orbiting around sun-like stars. We've kind of come back around now as we talk about the Habitable Worlds Observatory. But this was a very ambitious mission that was planned early on, that it would be an interferometer. You would have multiple telescopes flying in formation. They would have a baseline for the separation. And they use a technique called nulling interferometry. And so you would be able to have, because you would be using two telescopes that are observing the same object from a gap, you could null the observations between them and be able to reveal the fainter planets. It's like a coronagraph, but a different technique to do that you only get when you build an interferometer. And that was canceled because it was just going to cost all the monies. And then you think about, say, the X-33, the Venture Star. NASA and Lockheed Martin were working on this potentially reusable rocket plane that would be able to take off, carry a payload to orbit, return to the Earth, and then be refueled and used again. And they were having problems with the fuel tank. They weren't able to make the composite materials work. And ultimately, it just ended up being too expensive and probably wasn't going to deliver enough payload into orbit. Single stage to orbit is a really tricky thing to make work, and nobody's ever been able to pull it off. And that's why with SpaceX, for example, with Starship, they've moved to a multi-stage rocket. But now we're living through the sort of the modern version of this, and that, of course, is the Mars sample return mission, that the Perseverance rover was supposed to collect samples on the surface of Mars so that they could be picked up by this sample return mission. Well, Perseverance has done its job. It's got the samples, but it looks like there's not going to be a mission from NASA to actually go and retrieve those samples, that the cost overruns were getting too high. Now, maybe we'll see this mission return and maybe we won't. And so this is what it feels like to have missions that you're excited about get canceled, delayed, and then everybody just forgets and moves on. And this is just a handful. There are probably dozens of canceled missions that I could talk about, each of which is incredibly exciting. And maybe I will. I really should. I know you guys would love to hear about that. So thanks for the suggestion, Ryan. Now, if you are a patron and you want to suggest rants that you want me to go on at the end of these episodes, we'll put a link down in the show notes that you can add to the pile of spice. You control the universe. All right, we'll see you next time.